Today I'm going to give you a little tutorial on area model multiplication. It's also known as the box method or the box model. If you search YouTube, for instance, you'll find videos about this. We've started a new unit, which is Module 8. It's 2-digit by 2-digit multiplication. So today, in one of my classes, we had some programs today, we were able to estimate with 2-digit by 2-digit numbers. So our first problem that I'm going to work as an example is 61 times 31. There are two ways to estimate. When we have both of these numbers, both factors can be estimated or rounded to tens numbers. That would be easy. So this number would round to 60, and this factor would round to 30. And we know that our basic fact, 6 times 3, is 18, and we have 2 extra zeros. So we practiced this a lot in class. I bet the kids would be awesome experts at multiplying with zeros, because that's a quick and easy way to estimate that problem. But if we want to find out if our estimation is reasonable, we've just learned today how to multiply 2-digit by 2-digit numbers using area model. So let's get this started. I'll rewrite the problem, and we will use expanded form like we have in our previous unit. But we're going to expand both factors. This will be 60 plus 1, and this is 30 plus 1. How we set this up, what I'm going to do in class is the first factor will be going down the side of the box. The second factor will be going across, and you can switch them. The only reason why I'm doing that is so that when we check our answers, the kids won't get confused. So I'm really trying to make sure to get the process down before we start really playing with it. So down the side of the box, we will write 60 and 1. Because what we're saying is that we have 61 rows, which this is this number, 60 and 1. If you want to write the plus sign there, that's fine. 60 plus 1, that would be 61 rows, times 31, which we broke down into 30 plus 1. I told the kids they could write or draw their line where the plus signs are, so that can help them remember to make the line across there. Okay, so what will go in this box? Okay, here we're multiplying 60. If we're looking at this section right here, we're multiplying 60 times 30. So we'll write that in the box, 60 times 30. If we were looking at this as a multiplication array, it's just 60 times 30, and it meets right here. I told the kids that when you look at these problems, what to put in each box is just like when you use a multiplication chart. So 60 times 30 would go here. In this box, it would be 1 times 30. So I'll do that in a different color. This would be 1 times 30. And that would go in this box. In this box, it would be 60. You go straight out. 60 times 1. And then in this box, it would be 1 times 1. All we're doing is multiplying the values of each digit in one factor times the values of each digit in the other factor. So what we'll now find are our partial products. So 6 times 30, basic fact is 18 with 2 extra zeros. Basic fact is 3 with an extra 0, but 1 times 30 is 30, of course. In this section, the value of the 6 in this number is 60 times 1, which is 60. And then the value of this 1 times this 1, which is right here, is 1. These are called partial products. And all we have to do is add these numbers and we'll get our answer. So we have 1,800, 60, 30, and 1. So there's 1, 9, 8, 1. Our answer is 1,891. And look, it's awfully close to our estimate. So that's how you work this problem. We're going to work a few more. I just wanted to give you a quick overview on how these box models work. Okay, the next problem I'm going to give you is 52 times 68. Now one method, again, is to round both of our factors to the nearest 10 since we're working with tens numbers. So this would round to 50. This would round to 70. So 50 times 70, our basic fact is 35 with 2 extra zeros, so 3,500. Okay, easy, easy. Let's set this up using our box method or our area model. So what we're saying is we have 52 groups of 68. So if we were to draw this out in a big multiplication array, we would have, I'm going to make this one a little bit larger. We would have 52 groups of 68, and it just looks like it's a multiplication array. All we're doing is we're simplifying it. So this would be 52. So you can write this going down, 52, and this factor would be written as 68. We're simply splitting them apart using expanded form. Okay, so just like a multiplication chart, we're going to multiply in this box 50 times 60, and that's what will go here. That's our partial product in this spot. So 50 times 60, our basic fact is 30, and we have 2 extra zeros at the ends of our factors. Okay, this box will be the value of this 5 times the ones place in the other factor, so 50 times 8. Which is 40 with an extra 0. It's 400. We're just working our basic fact and our extra 0. Okay, now we're multiplying the value of this 2, which is just 2, times the value of this 6 in this factor, which is 60. So it says right here, 2 times 60, and that's the box where we will meet, which is 2 times 60. So our basic fact is 12. With a 0. So that's 120 will go in that box. And then they have our ones places multiplied together. The value of the 2 times the value of the 8, which is 2 times 8, which is 16. So now all we have to do is add all of our partial products. So 3,000 plus 400 plus 120 plus 16. Okay, so we have all of these numbers added. These are all of our partial products. 0 plus 0 plus 0 plus 6. 2 plus 1 is 3. That's 5, and that's 3. 3,536. All right, not so bad. Let's try one more. See how it goes. I'll do pink. Okay, 26 times 44. Okay, now this is a different kind of estimation problem. What we can do is we can use what's called a compatible number. Now, a compatible number is an easy number to work with. And when we're multiplying or counting, we can easily count by the nearby number 25 because we know we have quarters, and each quarter, we've been counting by quarters for a long time, so we know that we have 25, 50, 75, 100. So a group of 4 would be 100. So let's go ahead and round this down to 25. That's called a compatible number with 26 when we're multiplying. Okay, and we can round this by using tens numbers. So that'd be times 40. Okay, so we know that 25 times 4, or 4 times 25, if we think of money, 4 groups of 25 would be 100 cents. Well, so that's easy to multiply in our head, and we have our extra 0. So we know that that's going to be 1,000. So let's set it up using our box method. And this time, I'm going to show you, the parents, how this actually relates to a traditional multiplication problem. All the box method does is kind of separate it out and shows how we are multiplying, and that we really are multiplying the value of each digit times the value of each digit in the other factor. So let's set this up. I'm going to move it over a little closer. So we have 26 times 44, which I will rewrite. here. So first factor we're going to write going down. 20 plus 6, 20 and 6. We'll expand them. And then this is going to be 40 and 4. Okay, so we're just expanding the first one going down and expanding the other number going across. We're still going to be multiplying all within this box. Okay, so I'll set it up to the side. 26 times 44. Okay, well, if you think about it, in a traditional multiplication problem, we're going to start with multiplying 26 times 4. So really, the problem that we're working in this spot is what? 6 times 4, which is what we're multiplying here. So I find it interesting. When I first learned this method, I thought, oh, I never knew what was really going on inside this problem until I saw this. Oh, it's each digit, its value times the other digit, the other number. It's really kind of cool if you look at it. So let's work these as we go through the traditional. So 6 times 4 is 24. So I would put this down here, 24. So here's your 6 times 4, which is 24. So there's your 24 and there's your 24. Okay, the next multiplication we're working is 2 times 4, which is really 20 times 4. That would be 80, plus 2 more 10s, which is what? It's 100. So let's look over here at our box model. We have 2 times 4, but it's really 20 times 4. That's what's going here. We're multiplying times this ones place number. So that's where all this goes. So 20 times 4 is going to be 80. And we'll pick up these other two right here in this spot. So if we thought about it, let's go ahead and write this down. If we added these two partial products, don't we have this number? We do. We have 104. So it's just kind of laid out the same. It just, I don't know. When I saw this, it kind of explained a lot to me. So we're finished multiplying by this digit. So we'll start over with this 4, which is 40. That's why we have this 40 here. We're multiplying this ones place number times 40. That's why we put that 0 right here in our traditional. We're really multiplying by 40, so we know that that's going to end with a 0, so that's why we mark that spot with a 0. So 6 times 40, that's where that 0 comes from. So 6 times 4 is 24 with a 0. So I'll write that down. That comes up. And then again, we're multiplying 2 times 4, but it's really 20 times 40. So here in this box, we have 20 times 40, which is 8 with 2 zeros. It's 800 plus this 2. That's where it appears right here. So that's 10. If we add these two partial products, won't we get what's on this line? Let's look. Sure enough, this is where we get this information. This is where we get this top line of information. It's really the same thing. It's just broken apart. Okay, so we have 4, 4, 1, and 1. If we add these two numbers together, I'll bring it down underneath. And looky there, we have the exact same answer. This is what we're going to be doing. We're going to be looking at several different methods of multiplication. This has been really successful the last 2 days. Both classes have had a different amount of exposure to it, but we're going to practice it a lot the rest of this week. I hope you enjoyed the video. Thanks!